Now I want to introduce you to one of the analysis techniques available within OpenBio, and that's global sensitivity analysis. As you can see, I still have the circadian rhythm clock model open within OpenBio, and previously I showed you how to run a simulation by clicking on the Computation tab and the Simulation tab. Well, global sensitivity analysis is also available under Computations. You can see it's right under Simulation there. And the first thing you need to do to start the global sensitivity analysis running is to right click on this node and select New, and we're going to give it a name, GSA1. And now an input screen will open where you'll tell it which simulation to use, which variables you're interested in, and which parameters you're most interested in. So the base simulation is just the default sim that we used previously. We have to tell it what variables to study. So if you click on the Add button, you see all the variables available in your model. We're going to select all of them. And also which parameters to study. So basically what this is asking is how do the parameters at the bottom affect the outputs or the variables at the top? So we're just going to select all of them using this button here, and we have to give it a range. So shown in the second column is the value for all of these parameters, and we have to give it a range because this method uses random sampling between an upper bound and a lower bound to try and figure out whether this parameter is sensitive or not. So what I'm going to do is just click this button, Set Selected Bounds with Scale of 2. And what that'll do is it'll change the lower bound and the upper bound for every parameter down 2 logs and up 2 logs around its nominal value. The last thing I'm going to do is tell it how many times to sample. So this is, like I said, a random sampling method where you come up with randomized values between the upper bound and lower bound for all the parameters, and then you calculate the sensitivities and then repeat that process until you get what we call a global sensitivity analysis. So what we've found is that anywhere from 100 to 1,000 iterations is usually sufficient for global sensitivity analysis. But for the sake of time during this demo, I'm just going to put 10 in. I'm going to hit Control S to save. And now that it's saved, I'm going to right click on the GSA1 and hit Execute. Now what you'll notice is at the bottom you will see computations start to finish. So it'll tell you each iteration and its computation time. So iteration 1 is done, iteration 2 is done, 3, 4, so on and so forth, up till we get to 10. So while this is finishing up, I do want to mention that OpenBio has parallelization built into it, so you can submit jobs to parallel computer clusters using Remote Runner. You simply say submit job to Remote Runner, and everything's taken care of. All the computations will be sent to the cluster in an automated fashion. There's no code or anything that needs to be written, so that can be very helpful, especially when you're talking about doing 1,000 iterations of GSA. Well, now that the GSA is finished, we want to view its output. We simply right-click on the GSA1. You go to View Output, and again, you'll notice a 4-panel results viewer comes up, very similar to what you saw before. And so what we want to look at is how all the parameters on the right affect the variables on the left. So let's say we want to select all the variables, and we want to go to up here and select all the rates, and hit the Update button, and you'll see that the other panels have now updated. Now to the right is the output table. So this is all of the sensitivity data for each of the variables rank ordered. So the first tab is for the variable nuclear per, the second tab is for the variable total per, so on and so forth. And you can scroll along this to see all the variables in your model. What's nice about this table is, for instance, you can click on nuclear per and you can click on the value tab, and what that does is it sorts them by it sorts them from highest to lowest. So for instance, what this is telling you is that parameter 17 K2 RPN2 is the most sensitive parameter controlling nuclear pers, the amount of nuclear per. And so you can click on that and hit the update button again. And what that'll do in the pathway diagram now on the bottom right is it'll show you where K2 RPN2 lives within the topology. And if we zoom in, you can see that nuclear per is directly connected to it. So it's in this picture, it's node 10. You can blow this up by double clicking and size it. And you can see where that sensitive perimeter lives in the topology, and also how it's connected to the model in the reaction list. So now I'm going to double click that again to minimize it, and I'm going to show you the last window, which is the GSA output chart. So the output table in the upper right is an easy way to see all the values and sort them, but the output chart is an easy way to graphically see the values of all the sensitivities. So if you double click that, you get this chart, and this is in beta. We're going to have this labeled and resizable in the upcoming week or two. So all the variables are listed from 0 to 5, and all the parameters are listed from 0 to 17. So the parameter we were just looking at, nuclear per, is in red here, and you can see that that variable, that parameters 11 and 17 are the most sensitive for that. Some of them have 0 sensitivity, which is also important to know. So that goes along with the table that I just showed you in the upper right, that parameters 11 and 17 are the most sensitive for the nuclear per. So this is an introduction now to global sensitivity analysis. I hope you get a sense for how easy it is to run and to view the output. And we'll be back with the next tutorial on parameter estimation.